One of the skills that you guys are going to need to be able to do when it comes to looking at how much of a particular type of element happens to be in a compound is called percent composition. And so what we're going to do is I'm going to give you 3 examples of how to calculate the percent composition of a single element within a substance. So we're going to do this first for the compound ammonia, NH3. So how to calculate percent composition? What you do first is determine all of the elements that happen to be in the substance and figure out how many of those atoms happen to be of each element in the substance. So there's 1 nitrogen and 3 hydrogens, and multiply them times their respective average atomic mass unit from the periodic table. So for nitrogen, that's 14.01, and for hydrogen, 1.01. And then sum up the total of each. So for all of the nitrogens, which there's only 1, is 14.01 AMUs, and for all the hydrogens is 3.03 AMUs. And then you sum that all together. That ends up being 17.04 AMUs. And to figure out the percent composition of each element, we're going to take the total value of the amount of AMUs for that element and divide that by the total amount of the formula mass for the entire compound. So for nitrogen, that would be 14.01 AMUs divided by 17.04 AMUs for the entire substance, and then multiply that times the 100 to give a percent value. And when you take 14.01 and divide by 17.04 times 100, you get 82.22%. So that should be in 4 significant figures. For hydrogen, this would be 3.03 AMUs divided by 17.04 AMUs times 100, and that gives you 17.8%. 3 significant figures because of the amount of AMUs for all the hydrogen. So this is the percent composition of all of the nitrogen elements in ammonia and all of the hydrogen elements in ammonia. All right, let's go to the next problem. So problem number 2. In this problem, what we want to determine is the percent composition of a part of a substance. And this particular one we're going to do is of water. So we want the entire compound, all of the H2O components of this compound that's called copper 2 sulfate pentahydrate. So we go through the same process of determining the total formula mass for the entire substance. So that's copper, sulfur, and oxygen in this first part of the substance. And then because we're going to figure out all of the water values, I'm going to separate that out, and we're going to do hydrogen and oxygen again. And so for copper, we know that there is only 1 atom of copper in that entire substance. There is 1 atom of sulfur, 4 oxygens in the copper 2 sulfate part, 10 total hydrogens, and 5 oxygens. And we're going to multiply those times each of their atomic masses. For copper, that ends up being 63.55. For sulfur, 32.07. Oxygen is 16.00. Hydrogen is 1.01. And again, oxygen 16.00. And then we're going to sum up for each element the total amount. So for copper, this still ends up being 63.55 AMUs. Sulfur, 32.07 AMUs. And then for oxygen of the copper 2 sulfate, it is 64.00 AMUs. Hydrogen, because this is 3 sig figs, we will put that as 10.1 AMUs. And then for oxygen in the waters, all the oxygen in the waters, it ends up being 80.00 AMUs. Again, you're going to sum all of those together. And given the fact that you're summing, so you're going to go to the first decimal place based on the rules for addition of significant figures, you will get a value of 249.7 AMUs. Now, what you want to do is take all of the values for all of the components of the water, which this ends up being 90.1 AMUs, and divide that value by the total and multiply it times 100. So this is 90.1 AMUs divided by 249.7 AMUs times 100 gives you a value of 36.1%. So there you go. All of the water out of copper 2-sulfate pentahydrate is 36.1% composition. All right, let's try our last problem. This is a problem where we are going to determine the percent composition of calcium ions in a substance called calcium phosphate. And the reason why we're saying calcium ions is just because this happens to be an ionic compound. And so because it's an ionic compound, when we refer to either the cation or the anion that happens to be in it, we just call them ions. But essentially we're wanting to know what is the percent composition of calcium. So to start out with, we're going to determine the formula mass of calcium phosphate. So we know there's 3 calciums, 1 phosphorus, 4 oxygens. Multiply them each by their respective atomic mass unit. Calcium is 40.08, phosphorus is 30.97, oxygen is 16.00, and that sums up to be 120.2 AMUs, 30.97 AMUs, and 64.00 AMUs. And when we add all of these together, we end up getting a value of 215.2 when we round that to the appropriate significant figures. And now what we're going to do is we're looking at calcium specifically. So we're going to take this value and divide by the total formula mass times 100. So 120.2 AMUs divided by 215.2 AMUs times 100. And that gives us a percentage of 55.86%. And that's our answer. So we're going to use percent composition when we go on looking at things like empirical formulas and molecular formulas. So this is a really good tool for calculating some other things. I recommend practicing calculating percent compositions for other problems, and we will practice these in class later on. All right, that's it.